Hello everyone, this is Prithviraj and today's topic is Floyd's algorithm that comes under Module 4 Dynamic Programming. Floyd's algorithm is also called as all-pair shortest path problem, and this algorithm is used to find the shortest path between every pair of vertices in a given graph. For a graph G is equal to V, E, where V is the set of vertices and E is the set of edges, the cost be the weight of adjacency matrix such that cost of I, is equal to 0, cost of I, j is a cost associated with that edge I, j, and cost of I, j is equal to infinity if there is no edge from I to j. Let us see the steps to solve the given problem. First, calculate the weighted matrix for the given graph. Select the first row and first column of the matrix in the initial iteration. Calculate the new distance using the formula d of ij is equal to minimum of d of ij, d of ik plus d of kj. Update the new distance values in the matrix and repeat the steps 2 to 5 for all the rows and all the columns of a given matrix. This is the given problem. Solve all pair shortest path problem for the given graph using Floyd's algorithm. Let us take the graph first. First thing is we have to calculate the weighted matrix for the given graph. Now weighted matrix is nothing but suppose if there is an edge from one vertex to another vertex and we have to note down the cost associated with that particular edge. If there is no edge, then we have to if there is no direct path from that vertex to another vertex, then we have to make it as infinity, and the cost from same vertex to same vertex will be always equal to 0. This is the adjacency weighted matrix for the given graph. From A to A distance is 0, A to B there is no direct edge or direct path, hence we have to make it as infinity. From A to C we have a direct edge with the cost 3, so we have to write down the cost as 3, and from A to D we don't have direct edge, hence it should be infinity. Similarly for B, C and D. First thing is we have to select the first row and first column of a matrix. Well, let us take this as D0 or D0. Note down the values across row as well as column. Across the column we have B, A is equal to 2 and D, A is equal to 6. We have to note down only the valid values. And across row we have A, C is equal to 3. Then B, A equal to 2 and A, C is equal to 3. Then we have to find out the distance from B to C. That means there may exist a distance from B to C, but the intention is we have to calculate the shortest distance. So let us apply the formula as we discussed. D of ij is equal to minimum of D of ij, D of ik plus D of kj. First we'll solve for B, C, which is equal to minimum of B, C, B, A plus A, C. B, C is equal to minimum of, now the distance of B, C in a matrix, the distance is for B, C, which is infinity, distance of B, A, so B, A it is 2 plus distance of A, C which is 3. That means minimum of infinity, 5. So minimum value compared with the infinity and 5 is 5. So we got the new distance as 5. The second pair D comma A is equal to 6 and A comma C is equal to 3. Then the distance from D to C. Same thing, again we have to calculate D comma C is equal to minimum of D comma C comma D comma A plus A comma C, which is equal to minimum of infinity comma D comma A. So D comma A is 6, then A comma C is 3. So minimum of infinity comma 9. So minimum value is 9. So this is a first iteration by combining first row and first column of a matrix, and whatever the value that we got, we have to update in a given. We have to update in a matrix. Okay. So here we can observe 5 and 9. That is the newly value that you got in this iteration, and let us take this as D1. Next we have to select the second row and second column, and we have to perform the same process. Let us take this as D1 and note down the values across the row as well as column. In column we have C comma B is equal to 7. Okay, so only one value we have in column, that is C comma B equal to 7. In row we have B comma A is equal to 2 and B comma C is equal to 5. And take the combination C comma B equal to 7 and B comma A is equal to 2. Then the path from C to A. Calculate the path from C to A using the formula C comma A is equal to minimum of C comma A comma C comma B plus B comma A. So that is initially C comma A is infinity, as you can observe in the matrix. Then C comma B is 7, B comma A is 2. Minimum of infinity comma 9, that is 9. So C comma A value is 9. Next C comma B equal to 7 and B comma C equal to 5. Then what is the distance from C to C? Now here you can observe for C to C, minimum of C comma C comma C comma B plus B comma C. In the matrix, the distance from C to C is 0, comma C to B is 7, B to C is 5, 7 plus 5 is 12. So it should be 0 actually. Minimum of 0 comma 12, so value will get as 0. Okay, because the distance from C to C is always 0. Now update these values in a matrix. This is the value that we got in this iteration. Let us call this as D2. Next select third row and third column, and we have to repeat the same process as we done in the previous iteration. So note down the row wise and column wise values and take all the combination, first A comma C and C comma A. Then we have to check for A comma A. Obviously we know that initially A comma A distance is 0, and whatever the distance we will get, minimum value would be 0 only. But we have to compute the iterations. So first let us see for A comma A. Here we will get a minimum value as 0 comma 12. So minimum is 0. Next A comma C and C comma B, calculate for A comma B. We will get the value as 10. Then A comma C and C comma D, calculate for A comma D. We will get the value as 4. Next again we have to perform remaining combination with the B comma C. Next combination is B comma C and C comma A. We have to find B comma A. So B comma A will get it as 2. B comma C and C comma B, we have to find B comma B. Obviously B comma B value will get it as 0. B comma C and C comma D, we have to calculate for B comma D. We will get B comma D as value 6. Then last one, D comma C and C comma A, we have to find it for D comma A. So D comma A will get the value as 6. D comma C and C comma B, we have to find it for D comma B. So D comma B will get the value as 16. D comma C and C comma D, we have to find for D comma D. So obviously again the D comma D, the distance will be 0. Then whatever the value that we got in this step, we have to update the value in a table. Sometime we may get the same values, but whatever the value we'll get, just let us update it in a matrix. So that will be useful for the next iteration. Let us call this as D3. Lastly, we'll select the last row and last column, that is fourth row and fourth column, and note down the values which is present across row as well as columns. We have 3 valid values through row as well as 3 values across column. And let us combine these and find out the new distance. A comma D equal to 4, D comma A equal to 6. Then we have to find for A comma A. Using this formula, we'll get the shortest distance or minimum distance as 0 only from A to A. Then A comma D, D comma B, we have to find it for A comma B. So for A comma B, we'll get the value as 10. A comma D and D comma C, then we have to find it for A comma C. So for A comma C, we'll get the value as 3. Next, perform the next combination with the B comma D. So B comma D and D comma A, we have to find it for B comma A. B comma A is equal to 2. Then B comma D and D comma B, calculate for B comma B. So again B comma B will get the value as 0 only. B comma D and D comma C, calculate for B comma C. So B comma C, we got the value as 5. Okay, next we will find the combination with C comma D. So C comma D and D comma A, find it for C comma A. So C comma A is equal to 7. C comma D and D comma B, find it for C comma B. So we'll get C comma B as 7 only once again. Lastly, C comma D and D comma C, find it for C comma C. So for C comma C, again we'll get the value as 0. So these are the values that we got in the last iteration by selecting fourth row and fourth column, and update these values in a matrix. Okay, so these are the values that we obtained in this iteration. Some of the values we may get the same value. That means here the thing is, our intention is to get the shortest distance from one vertex to some other vertex. Let us take this as D4. So for the given graph, we have all pair shortest path that is given in the following table. And by looking at this table, we can see that whatever the value that we obtained, that is the shortest path from that vertex to any other vertex. Let us consider the first vertex as A. From A to A, the shortest distance is 0. From A to B, we have a shortest distance 10, that is from A to C and C to B, that is 3 plus 7. So that is the shortest distance. From A to C, that is 3. From A to D, that is 4. That is from A to C and C to D. Like that, we have all the shortest distances from all the vertex to all other remaining vertices. So that's all about Floyd's algorithm. So this is used to find the shortest path from every pair of vertices. And this is a problem for you to find the shortest path for this given graph using Floyd's algorithm. Thank you all.